So basically, yeah, that's the PIN2DMD, the one which you just saw in my video. And yeah, what is it? It's a DMD for pinballs, and as you can see, it's an RGB DMD, and it uses two panels. So at least my version uses two panels with 1mm LEDs. And those are usually used for those large soccer or live event video walls, and that's basically two panels from China. And there's also a PCB with a controller. I can turn it around later and show you if you want. So there are like multiple versions of this hardware. It's developed by a German guy. He's called Lucky One, and another guy helped him or started when he started. Another guy joined quickly afterwards. The first version was basically STM32 based, but it's no longer supported since starting this year. And yeah, it has been basically a separate board which then connects to the China panels, and you needed a mounting bezel, so it has been a little bit more effort to build it. And the newer ones are called Evo, and there are like 3 versions for different resolutions. The one I got is 128x32 pixels, which is the standard pinball size and the standard pinball resolution for modern machines. And the parts are around $100 roughly. And then there are 2 versions with 100, so one with 192 versus 32 pixel, and the other one is 192 versus 64. So it's a lot higher and wider and higher. And those are a little bit more pricey, but not much. You can actually buy those in pinball supplies. So I got this from a German supplier, which fabbed the board on their own in China, and gave me the whole package. So that's pretty nice. I think I paid 190 or 89 euros, so 200 something dollars. But that's because I got some extra options. I will come to that later. So yeah, those are three versions. So the 3 Evo versions which you might want, and those are basically available commercially, or you can also fab them yourself. That's technically possible. So the hardware design is open, unfortunately just for non-commercial projects. If you want to use it commercially, ask them. And as far as I know, they want like a 20 euro like donation to a charity of your choice, and then you get like a commercial license for it. So basically per board it's 20 euros donation to a charity, which is then tax deductible. So it's practically for most companies it's also around 10 euros, $12 for the license. And the same as if you want to use it, if you just want to build it for yourself, you need a software license. As the software is no longer open, it has been open in the first version, but not in the second. And it's like 10 euros a donation. You can donate more, but at least 10, and I guess it's around $12 via PayPal. Yeah, and this board here, it works with existing machines, so you can plug it into your WPC machine or some Data East, and I don't know which exactly, but a lot of machines work, and you can use it as a replacement DMD for your existing machines, and also as an USB interface for virtual pinball and also for MPF, and that's why we are here. So that's what I also connected on my board here. And that's basically for the software. Yeah, something I forgot. Basically, if you build the board yourself, you could, for example, remove the interface from existing machines. It would remove a lot of parts from the PCB, and it would probably become a little bit cheaper, especially because of less connectors. Yeah, power supply, there are like 3 options. The easiest is like you need 5 volts at least for amps. So if you got a proper power supply like I do, then you can connect it to 5 volts, or you can connect it to 12 volts. That's basically what most of the boards support. There's a buck converter on it, which converts 12 volts to 5 volts, so that it can run off existing machines at around like 1 amp, which is okay for WPC machines, for example. I guess you can also get the hardware without the buck converter and it will be a few bucks less. And lastly, you can also get an AC option. I got that on my board. That's why it has been a little bit more expensive, but that's optional and I guess like 20 bucks or something. And then you can directly connect it to AC. I'm not using it at the moment. I'm using it at 12 volts, but it's on my board. So those are the power supply options. And this is basically available as hardware design. So it's super cool. And lastly, how DMDs work in MPF is the following. So as you know, if you used MPF, you show a slide on. So MPF tells the MPF media controller to show a slide, which then will be rendered by MC on the GPU, which is like, it sounds trivial, but it's a lot of hassle to do this on a CPU efficiently, and you will run into resource problems eventually. And you do not even need a strong GPU. Even a small built-in GPU is enough. It can do this easily, at least what usual pinball machines do. And then basically we grab the pixels from the GPU. That's not terribly efficient, but yeah, I mean, but it works. For those small resolutions, right? So if you want to grab full HD pixel resolution, that would be an issue for yeah, that actually would really be an issue for most GPUs, because like there's synchronization issues there. And lately, the media controller then sends those pixels to MPF over the BCP network connection there, the local socket, so it's not expensive, and MPF sends it to the hardware. So that's the general structure how this works in MPF. So theoretically, the MPF-MC could send this to the hardware, but as in most cases, the DMD is connected to some other hardware, or in some cases, the DMD is connected to other hardware interfaces. It makes sense to do this from MPF. So this could be a performance optimization at some point if it turns into a problem for somebody, but at the moment it works this way. So that's to the general structure here. So let me go back. So here we go back. So Greg, yeah, the resolution is I mean, yeah, you mean the DPI, right? So basically the dots per inch, that's how it's called, right? I think it's the same. I mean, technically you could put any panel on this board, but I think it's physically larger, yeah. So the board is physically larger, which is, I mean, which is nice, right? So if you build a new machine, those old DMDs are rather small, and now you can have like a larger DMD. I mean, I personally like the look of DMDs, so but it's a matter of taste. Yeah, I mean, for LCDs, it's exactly the same. You're right. So except that we do not grab the pixels, right? Because that would be slow at the end. But otherwise, it's yeah, it's the same. So you do not have to change any general structure in MPF for DMDs. So if you look at my small there it is, my small virtual DMD, that's basically also just a filter, right? So I take this display. So yeah, let me put one more thing. So in MPF you got displays, and this is technically two displays. One display is like this window. It's the whole display, and inside this inside this box, I show another display. It's called DMD in my configuration, and that is then shown with a pixel filter, like so that it looks like a DMD here. And now if I can also press something here, which is probably a little bit hard to see. Then this is basically some widgets which I show, and those will be rendered on this display. They will be shown on the real DMD and on the virtual DMD. Also here. So yeah, how does this work in config then? I'll show you. So this is basically my editor. It's Visual Studio Code, which with like the MPF language server, right? So that's the stuff which can highlight all the configuration for you here. So for example, if I want to know what I can use in this hardware section here, I can just press Control space and it will tell me what's possible here. Like for example, what do I want to configure? DMD, and then I can also tap here. It doesn't know which hardware exists, but it knows some stuff. And if I put in Gogo stuff, it will also tell me that this is not a valid config key in hardware section. And what we need to configure is basically the hardware. So we need to tell MPF that for an RGB DMD, we want the PIN2DMD platform, and then we can configure the PIN2DMD in the PIN2DMD section. And that's I added debug true here because I want all the outputs which you wouldn't want in production, but while playing around, it's usually a good idea. And yeah, I can tell it the resolution I got, and now it tells me that I'm using the default resolution. I guess I can also ask MPF what it supports and select some other options. I want this one, and then depending on which panels you got from China, the color order of the LEDs might be different than RGB. So mine are RGB, but they might also be GRB, same like on all the serial LEDs. But you can configure it, and that's basically it. And that's also all the options. There are no more options here except logging options. Then, as I told you, I got one display for the DMD, which ideally has the same resolution, otherwise we will run into issues. It's always recommended to set those settings: round, anchor, X, and Y. That's because if you put something centered, which has an uneven number of pixels, MPF will calculate the center point, which would be then on a half pixel, right? And that will lead to weird aliasing effects on like stuff like a DMD with low resolutions. So on high resolutions, like an LCD, that looks fine. Yeah, like on high resolutions, that looks fine because anti-aliasing at high resolutions is proven and it works. But having half, so like if you have a line and it's exactly on 1 pixel, and you move it by half a pixel to the left, it will be basically both pixels will be half on, and that will look really, really bad on a DMD. That's why you usually want those options. So that's also my default display. So if I do not specify it, I will render my slides and widgets on this display. And then this one is the display which I've shown you here, basically the on-screen display. And yeah, then I configure my RGB DMDs section. So that's basically the MPF equivalent of this PIN2DMD display. and you can configure all kinds of stuff here. For example, like how many FPS do we want to send to it? You can configure, for example, gamma. That's sometimes useful. We got, I think, sensible defaults, but you can change that, and you can also change brightness and so on. That's then rendered on a shader on the GPU because that's rather expensive. Then there's also hardware brightness. That basically only affects how bright the hardware will be lighting up, right? So that's sent to the hardware and not will not affect the software side. And we will come to that later. For now, I will set it to 0.5, 50%, but we will come to that later. You can configure some other stuff, but that's not so important here. That's basically the most important thingy here. And now, as you saw earlier, we can write something in chat, like here, and it will show like the message on the DMD. Yeah, that's like I put on some default slides, and that's already what it is doing here. So yeah, I can show you the real hardware now if you want. You showed it earlier. So that's basically my camera here on the real hardware, which with the editor on top. And now if I play, say hello hardware, then it shows my message there also. It can also do some other stuff, like for example, see if this works. Okay, yeah. I should have scaled down the image, but I mean, you get the idea. So that's how this works. And I mean, that's all the configuration I showed. That's all you need to make it work. So that works pretty much out of the box. I mean, make the fonts a little bit smaller because the resolution isn't as high, but that's how it works. And yeah, I mean, I added 3 colors, so it's not 4 colors. I think every message gets a different position and a different color. That's just for playing around a little bit. So now one of the common things, I guess, which you want now is you want to change brightness in service menu, I guess. And I showed you just a minute ago that I set the brightness to 0.5, right? So here it is. Hope it's large enough. Yeah, that's basically, I can just zoom in a bit. I set brightness to 0.5, and the easiest way just to do that is basically creating a settings entry. So I just did that. I did a settings entry here with type float, default 0.5, and it has then the values from 10% to 100%. And we call it DMD brightness, and yesterday we added the settings type, which can be something like, that's basically the category in the audit in the adjustments menu, right? So let's put it in the feature menu just to play with it. And now we just reference it here in brightness. So let's say settings RGB brightness. Yeah. So then let's restart the MPF instance here, and I'll show you the hardware again. So MPF restarted, and now we can show some stuff. It still works. It's generally good, I guess. And we can, yes, service menu rocks. But as you can see, it's not very bright at the moment. So we can go to adjustments. I mean, the service menu is pretty much optimized for this resolution of DMDs, right? For LCDs, the slides aren't as nice at the moment. And now, oh no, I did put it in features, right? So let's go into feature adjustments. And now we got a new setting here, which is called DMD brightness, and it's now 50%. And now you can see a firmware bug in the PIN2DMD. You see that? It flashes the screen. It's actually a bug in the firmware, which has been fixed in the latest PIN2DMD firmware, but I didn't update yet. But here you can see that. I mean, you can slightly see it that it gets a little bit brighter. 100%. Now, now you can see it a little bit, and now we can test 100%, and it will show. Yeah, that's a lot brighter. And yeah, that's basically what you can do to make this configurable at runtime. I think there's also command. Let's see how this looks. That looks awesome. I'm happy about that. The text should be a little bit smaller. I'm not sure if you want to ship with 100%. It's really bright. It makes your eyes hurt a little bit. I'm not sure what Stern would do, but I think something like 70-80% or so. that would be better. I mean, this font is probably not very like DMD optimized. What I used here, it's just a default font. I didn't add a DMD font. If I did, that would be probably bold and also a little bit more pixel perfect. Yeah, I mean, that's basically how this hardware works and what it is. I don't know if you want to know anything about it. Yeah, you feel free to ask, and we can play around with it if you want. Yeah, it's just a DMD. So yeah, what I also can do is like I can turn it around. I got a lot of stuff on it, so don't be confused. But already, yeah, you can see it. So what I got on here is like that's basically the hardware. Here you can see what I bought basically, or where I bought it. They branded it nicely, and yeah, it's a very bright light here. Yeah, I power it off 12 volt here. There's also like this is the connector for AC, so that it's it's much larger. How's the performance when displaying animations? I mean, it can do like something 50-60 frames per second, so that's not an issue in the MPF side. So that's a Raspberry Pi here, and the Raspberry Pi 4, and with the Raspberry Pi 4, we can easily render 60 frames per second, but honestly, in my opinion, 30 frames are just sufficient. What it does though is like it uses a lot of time on the USB handler, right? So what we had to do for that is we put the USB handling on a separate process. because otherwise the Python global interpreter lock, that's how it's called, will block the other thread. So if you just use threads, it will block the other thread. So in Python, you actually have to multi-thread here because, I mean, technically you do not have to, but the library PyUSB is just, I mean, it's written in Python, that's the issue, and it's not that great in this regard. So it keeps the global interpreter lock, and even if you flush like stuff, keeps the lock even on a separate thread, and that will slow down the game. So separate process it is, and it works. It's no problem at all. So that Raspberry Pi runs like a 10% CPU at full frame with the DMD. So that's not an issue. I think USB is somewhere saturated at 60, 70 frames per second, and then it cannot handle more. But besides that, the hardware is fine. It can keep up. I even tried to like actually fork this USB code and write a version without global interpreter lock, and that actually worked. But when I also connected the PROC or a P3 rock, then libpiperock crashes because now my code flushes the other code, the other USB commands from libpiperock also, because it's using the same library in the background, and then just libpiperock got confused. I mean, it's probably bugs in that library, but then I said, well, it doesn't matter. I don't want to mess with it. Just put in another process and be happy with my life again. So what's the color range of the LEDs? So it's basically you send what do you send? A good question. I think it's just 4 bits. You send 4 bits of color, so not 8 bits. Other DMDs got more values, right? So the format is similar to the frame format from a Stern Spike or a Stern SAM. So you send like 4 frames, which then are stacked. So the first frame is like 50% brightness, second one is 25, third 12%, and the last one the remaining 6%. Exactly, yeah. So at least that's, let me check it, but I think that's how it's done. Yeah, that's how it is. Yeah, you can see it, and it's like 6 pixels, or is it 4 or is it 6? No, it's 6 bits. It looks like it's 6 bits. So they compress it a little bit. But I mean, at the end, everybody which tried the difference of an RGB LED between 1 and 2 knows that there hardly is a difference, right? So I guess that's fine. So in my opinion, it works pretty well. So the smart metric stuff has a little bit more resolution. I think they got 8 bits, but like all the Sterns, they got 4 bits only, and I guess nobody's complaining about that. Yeah. So this is basically here that's the connector for existing machines. So you could put like your WPC machine here, and yeah, that's 12 volts here, which you can see that here. That's where you typically connect in a WPC machine, and this is basically the 5 volts connector. And yeah, you can use either of those. I think it's a better idea to feed them both, then stuff would burn. But yeah, this way it works. So this is basically the converter is here, and below here, below my amp, there is like the 230 and 110 volt AC converter, which you cannot see at the moment. And what you can do with this is like you can actually use this to power. Let me find the connector here. Did I put it here? You can power like a Raspberry Pi off this buck converter as well if you want. So we can connect it here. And now the Raspberry here, you can see here it is booting. So that's now booting off the same buck converter here. So I mean, you have to make sure not to draw too much power. So I guess it's technically at the limit. So I mean, if you really use all the peripheries of your Raspberry Pi and maybe power USB devices, then this is not a good idea. But if you just want to use it to drive this DMD, then this is fine and it works. And yeah, that's what I'm doing with this at the moment. So that's the hardware, right? And let's see, I'll disconnect it again. Yeah, it has some buttons here, like you would imagine like the menu buttons where you can enter the menu and change settings, but it doesn't make sense to I mean, if you control it via USB, it doesn't make sense to use the menu, right? Because you can change all the stuff like brightness from USB as well. Is it a buck converter or an LDO? I don't know. It says XLS XL401 SE. And I guess we can Google it and then we know what we can do. It's like XL401. I probably already did that. You get my German results here. It's a buck converter, if I see it right. Let me change the view here. Yeah, that's what it is, according to the internet. Yeah, and I mean it has really a wide range, right? So you probably do not even have to feed it 12 volt. So you got it the data sheet. You could also feed it more value and more voltage. Yeah, like how's this called? You called an LDO in English. Yeah, I know them from in German. They're quite different. So yeah, they're getting hot if you give them a lot of voltage. So yeah, this one, let's see. I mean, just touching it is usually a bad idea, but yeah, no, it's cold. It's really you cannot see that I'm touching it. So this one here, so I feel it first, but it's cold. It's not even warm. And yeah, if you see 96% efficiency up to, and it even has 5 amps output current. And well, it looks, this is how it looks. I guess there will be some graph how efficient it will be, right? Let's see at load, full load, it's like around 85 to 90%. For 12 volt, it's the green line, but they all converge at the end. Yeah, I mean, you do not see that stuff is hot on electronics, right? And it can be really hot. So I guess you have to test it once. So you have to touch some constant current driver, which is like then 250 degree, and it will be just instant burnt. You just touch it, it's burnt. It's bad. You learn from that. So just always use your knuckle first and feel if it's hot, and then go closer. That's usually my personal advice. Yeah, I can imagine that this can happen. Yeah, I mean, when will solar melt like at 400 degrees, or I think it starts at like 250, 300, and 400 it will probably swim off in solar, and that at some point the magic smoke will come out. Yeah, so that's what they're using here, and so there's some headroom, probably not too much, but maybe in 1 amp or 2 it's available as headroom. So I would say this hardware is pretty solid. It's well designed in my opinion, and yeah, I mean that's also their like second or third generation, so it's not the first one, and it's all on this one hardware. You just screw those panels here. So when I bought them, that was all ready. So I only connected USB and it started working. Yeah, and I activated the license. So there you get basically a license file, and you can either put it on an SD card. That's an SD card slot here. And it's not so good to see, but yeah, that's basically an SD card slot, which can be used for coloring existing machines and so on. So yeah, and I think there's also like a Windows utility where you can also upload the license. Maybe there might be a feature soon with MPF where MPF can upload the license, but I don't know their USB command at the moment, so I need to ask them for that, because it would be cool to just automatically upload it based on some like app service if you want a lot of those displays maybe. Yeah, that's it basically. So yeah, you can also basically have got a screw mounting connector here for the voltage, so you can screw the 12 volts, but I guess that's more for install it yourself people, but I guess most of us got like those nice crimps, and I guess most of you will also have like a 4 connector header. I only had a 3 connector header, which I cheated. Yeah, I mean it's so why I showed this is basically it's a cheap hardware. It's like if you build it yourself, it's $100 roughly. If you buy it, 150. So in my opinion, it's a good option for adding a DMD to your homebrew machine, and also for your production game if you talk to them about the license. But I heard that they are very open about that. So I'm talking a lot. Guys, thank you for joining in. I wish you a wonderful week, surround with awesome people, and keep an open mind, keep hacking. So yeah, I'm out. Have a great time. See you next time.